Hello friends, welcome to Maths Concepts. This is the third part of our topic, knowing our numbers. In this video, we are going to learn about rounding off numbers and estimation. Now what is rounding off? Rounding off is to change the number to its nearest tens, hundreds, thousands or 10,000s to make the calculations simpler or easy. Okay. And what is estimation? To do these calculations by rounding off the numbers. Okay, it means to find the approximate closest possible answer to a calculation. Okay, now where do we use this rounding off or estimation in our day-to-day life? Let's consider one example. Okay, let's consider that it is your birthday and you want to distribute some cupcakes or say chocolates in your classroom. You don't know the exact number of students in your class, but you know that there are around 27 to 28 students in your class. So how many cupcakes would you take? Around 30, right? Because you don't want to run short of cupcakes or you don't want to carry too many. So this is approximation or this is rounding off. Okay, and this is how we use it in our day-to-day life. So now let's learn how to round off numbers. Let's first learn rounding off to nearest tens. Here I have shown random part of number line. I have just picked some random part of number line which has numbers from 539 to 551. Okay, let's consider that we want to round off number 543. Now the nearby tens to 543 are 540 and 550. 543 lies between two tens. Which ones? 540 and 550. Which one do you think is nearer? Of course 540, right? So 543 will always get rounded off to 540. Similarly 541, 542, 544, all these are nearer to 540 than 550 and these will get rounded off to 540. Okay. Now on the other side, 546, 547, 548 and 549, these are closer to 550 than 540, right? So these will get rounded off to 550. Now what about 545? This is equidistant from 550 and 540, isn't it? In such case, this middle number always gets rounded off to next tens, next, that is 550. Okay, and this rule, this same principle applies to all other rounding off also, like rounding off to hundreds or rounding off to thousands. Middle number always gets rounded off to next tens or hundreds or thousands. Okay, so which means we can say that numbers from 545 to 549 get rounded off to 550. So can we make a generic rule from this? If digit at one's place is less than 5, the number is rounded off to previous tens, that is one's digit becomes 0 and rest of the numbers remain same. And second rule, if digit at one's place is 5 or greater than 5, the one's digit becomes 0 and tens digit is increased by 1, that is we round off that number to the next tens. Okay, so these are generic rules for rounding off to tens. Now let's see rounding off to hundreds. Similar to earlier number line, I have picked up random numbers here. So this number line has numbers from 7590 to 7710 and the difference between two markings is 10. Okay, I have not shown the markings here because of space crunch, but we are going to consider those numbers as well. Now the significant numbers here would be 7601, then 7649, then 7651 and 7699. Okay, here all numbers from 7601 to 7649 are closer to 7600. Okay, the nearest 100 is 7600, and all numbers from 7651 to 7699 have nearest 100 as 7700. Okay, again this one is the middle number and gets rounded off to 7700. So we can see that numbers from 7601 to 7649 get rounded off to 7600, that is previous 100, and numbers from 7650 to 7699 get rounded off to 7700, that is next 100. And generic rule becomes, if digit at tens place is less than 5, then replace digits at tens and ones place by 0 and write rest of the digits as they are. Similarly, second rule, if digit at tens place is 5 or greater than 5, replace tens and ones digit by 0 and increase hundreds digit by 1, that is round off that number to the next hundreds. So these are generic rules for rounding off to hundreds. Now we will see rounding off to thousands. Again, here I have shown numbers from 17,900 to 19,100, and difference between two markings here is 100 units. Okay, again here we are going to consider the numbers that are not marked here but which are significant. Okay, here the first number will be 18,001, then 18,499, then 18,501, and the last one is 18,999, which is just before 19,000. Okay, again here numbers from 18,001 to 18,499 are closer to 18,000, which is previous 1000, which is nearest 1000. Okay, and numbers, and all these get rounded off to 18,000, and numbers from 18,501 to 18,999 get rounded off to 19,000 because they are closer to 19,000. Again, middle number gets rounded off to 19,000, the next thousands, right? So numbers from 18,001 to 18,499 rounded off to 18,000, and numbers from 18,500 to 18,999 get rounded off to 19,000. The generic rule we can make is for hundreds place, that is, if digit at hundreds place is less than 5, then replace digits at hundreds, tens and ones place by 0 and keep other digits same. And second rule would be for digit at hundreds place, if it is 5 or greater than 5, then replace all digits, that is hundreds, tens and ones by 0 and increase thousands digit by 1, because we are rounding off it to next thousand. Okay, so these two are generic rules for rounding off to thousands. Now this way we can round off the number to nearest 10,000s, nearest lakhs, nearest 10 lakhs and so on. So now let's consider estimation. Okay, we are going to use this rounding off in estimation. What is estimation? As I said earlier, to estimate is to find the closest possible answer to the problem using quick calculations. Okay, why do we need estimation? We want to find quick answers, quick calculations, and that's why we round off the numbers. It becomes easy to calculate and we find the estimate. Where do we use estimation? Again, to know the tentative amount that you need for shopping. Here is one example. If one pen cost say rupees 15 and 75 paise and you want 10 such pens, then you will quickly know that you don't need money more than rupees 160. And another example would be to double check your actual answers. So in exam, if you come across some complicated calculations, here say 178 into 98, you can quickly round off the numbers and you know this will get rounded off to 180 and this will be rounded off to 100, and you know that your answer should not be greater than 18,000, right? So this is where we use estimation, and there is some generic rule. There is one generic rule for estimation. What is the generic rule? Round off the numbers to its greatest place. Okay, whatever numbers that are involved in the calculation, round off those numbers to its greatest place. But remember, it is not necessary that you should use generic rule all the time. You have to take the call depending upon the situation or depending upon what you want to calculate. We will go to that also. I'll give you one example where you don't have to use the generic rule always. Now right now we are going to take the few examples for estimation of sum, estimation of difference, estimation of multiplication using generic rule. Here let's consider these two numbers. So we are going to use generic rule. So 427 will become 400, that is nearest 100, and 6790 will become 7000, nearest thousands. Because this is greatest place is thousands, we are rounding it off to nearest thousands, and the addition will be 7400. Now let's check what is the actual addition. 427 plus 6790, 7, 11, 12 and 7, 7217. Okay, 7217. This is close, the answers are close, but if you round off this number to nearest hundreds, the answer will be even closer. Okay, your estimate will always be closest when you round it off to nearest tens. Okay, and it will be the difference between your estimate and actual answer will be more if you, as you go on rounding off the numbers to hundreds, thousands, 10,000s and so on. Okay, here now if I round off 6790 to nearest hundreds, then it will become 6800, and 427 again I am rounding it off to 400 only, and this addition becomes 7200, which is more closer to actual answer, right? Okay, now let's see estimation of difference. Let's use generic rule again. 6790 becomes 7000 and 427 becomes 400. The difference will be 6600. Now the actual answer is 6790 minus 427, 10, 3, this becomes 8, 6, 3 and 6. The answer is pretty much close. Okay, again as I said, if you again change this, round this off number to nearest hundreds, answer will be even closer. Okay, let's see the estimation of product. 578 into 161, both numbers are 3-digit numbers. We will round them off to nearest hundreds using generic rule. So 578 becomes 600 and 161 becomes 200. So our estimated answer would be 1,20,000, the multiplication of 600 and 200. Now let's see what is the actual answer. 578 into 161. This becomes 6 8s are 48, 4 6 7s are 42 plus 4 6 and 6 5s are 30 plus 4 34. Then again 8 7 5 8 7 plus 8 15 1 12 plus 8 20 and then 7 plus 6 13 and this becomes 93,058. Now if you see, there is a huge difference between estimate and actual answer. Why? Because one thing we have used generic rule, and second thing, this is multiplication. The difference gets multiplied. So here in this case, if we would have rounded off this number to nearest tens, it would have been 160 and answer would have been much closer. If you know 16 stable, this product is pretty easy. 16 8s are 128, 16 7s are 112, plus 12 124, and 16 5s are 80, plus 12 92. So this is more closer, isn't it? Right? Okay. So as I said earlier, if you round off any number to nearest tens, the answer would be the closest one to the actual answer. And as you go towards hundreds or thousands or 10,000s, the difference between estimated value and actual value will be more. Here are a few examples for you to solve. You have to find the estimated value of these using generic rule. You can pause the video, you can write down the questions, find out the answers and check answers at the end of this video. Here are answers to all the questions. I hope you got them right. If not, please watch the video again to understand the concept. And this is all about rounding off numbers and estimation. Thank you for watching this video and don't forget to subscribe to our channel for more videos. Thank you. Bye-bye.